Yo, yo, yo! What's up, everybody? Welcome back. Today we're working on our neural network framework, training framework, I should say. And today's goal is to try to set up some sort of infrastructure that allows us to run many experiments overnight and compare the results later. So what you're looking at right now is kind of like where we're at. We have, this neural network thing. We have some visualizations here. He's trying to learn to predict the red box here. So he's like looking at barcodes on a blank background, which should be like a really easy problem, right? And he's trying to like draw a box around them. And the blue box is like where he is currently predicting. And we kind of did this yesterday. And what I found testing overnight is that I want to run many experiments here. Obviously, like this relatively simple problem that we're seeing right now, we don't have a good answer for yet. At the very least, he can't like train something that works well enough in the span of like a few minutes, which I think that we should be able to get something that like looks relatively okay relatively quickly. So I don't really understand why it's not doing that, right? And so what I want to do is I want to like set up experiments. I want to try different like neural network architectures and maybe like different training schedules, different learning rates, different loss functions. I want to try all sorts of different stuff. Um, and each experiment they might take like time, right? So I want to know like do I need to run for 30 minutes? Do I need to run for 2 hours? Like how long do I need to train to get something reasonable? Do I get something reasonable? How do these parameters compare to other parameters? And all of that type of stuff, right? So what I want to do is I want to have some way to define a bunch of experiments and then say, okay, I'm going to go to sleep now, run them overnight, and like tomorrow I can come back and look at the results and see which thing was kind of like the right direction to move, right? And so, uh, what that requires is some like maybe configuration files that allow us to define like the shape of the network, how which pieces where the data is going to flow through. Maybe also something that saves what the network output, right? So that later, like when we come in tomorrow and we see, oh, this one did really well. Can I look at what it actually looks like? I want to be able to like open that thing, the model, and like use the weights that I trained to like look at some data, right? I probably want to look at how some of our outputs train over time, right? So like if I change the learning rate and I see that the loss converges better, that's like a thing that I want to know. And I also want to know like the rate of convergence. So writing down things that we might be interested in so that we can make graphs to compare them later is something that we want to look at. And so that's kind of like where my head's at. Is I just kind of want to see how much stuff can I do at once. Doing batch learning first is probably the way to go. If you mean like one batch of stuff at a time, we are doing like we're doing batches of 64 right now, I think. So this is one batch here. What you're seeing. Um. Anyways, so that's kind of what I want to do is I want to make sure that we have everything in place so that we can run some experiments. And tomorrow, when we have the output of those experiments, write some code to visualize and compare. That's kind of what I want to do. And so I'm thinking defining our network at runtime via some config so that we can like have several different network architectures. Logging, our loss over time, maybe as well as like our iteration and like which iteration we're on and how many images we've seen, what the wall time is, that type of stuff. Writing down weights every once in a while and exiting so that we don't just train forever, so that we can like run 10 experiments in a row, auto queued overnight or something. That's kind of what I want to look at. And we'll see where it goes. Does it always have to be trained again from the beginning? And how is this knowledge even stated? Sorry in advance for the dumb question. Well, so as of right now, it does always have to be trained from the beginning, which is bad, right? So basically what happens is you have some sort of like sets of parameters somewhere, and those are like living on GPU. All we have to do is like take those, dump them onto disk, and then load them back later. Anyways, all right. Let's start by defining network via config. I think that's the big thing, right? Because like right now we kind of have hard coded somewhere this like neural network. Right, so this is just like a thing I tried where we do like a convolution that takes one input, he makes 4 outputs. We like scale this thing down. Then we go, okay, take those 4 inputs and create 8 outputs. Take those 8 outputs and create 16 outputs. Then like scale that thing down, you know? And this is just like hard coded in the code. So this needs to be something that we can like load from a config. That's the idea. So I guess the first thing we got to do is probably pass a config in from somewhere and figure out what to do with it. So I guess here, we'll call this network config, and he is gonna be like, yo, you need a network config for sure, right? Almost certainly, or we could have like a default, maybe. But for now, let's say that we'll pass one in. So if we see somebody pass a network config, is that what we want to call it? Sure, fuck it. We'll set the network config path to that place, and then we'll say if they didn't give us one, we'll say missing network config arg. And then at the end, we will try to propagate that somewhere. And if they didn't give us one, we have to get mad. Network config not provided. This guy needs to hold network config, you know, like this. And then we have to do something with that. Presumably this goes into the training thread somewhere, right? Because the training thread's the guy who creates the network. So we need to pass this along somewhere. Bing, bang, boom. Right, easy. And now it's just that we need to do something like, instead of hard coding these layers, we need to construct them from this thing. So whose job is this? Kind of feels like it belongs in like neural network.zig. The place where we define all this network, these like layers, seems like it could be the place where we do the config parsing. We could do like even this, where we have some config module. You know, like this. And what is going to be in this thing is undetermined. So he's gonna parse this thing for sure and return, maybe we say like config is this, and then we return a config, right? And this takes in like a path. And presumably this is gonna be some sort of like JSON blob of shit. So what does our like thing look like right now, right? We have kind of a list of guys in an array, right? So probably this is gonna hold like layers as a bunch of like layer definitions, maybe, right? And this is probably a union that, you know, could be the different types, right? So maybe we have something like convolution, right? And he holds the parameters that we use for the convolution. So we have like initializer, which is going to be, I guess, like an initializer. So we have HE and 0, I believe, are two weight initialization strategies. He is going to have, you know, the kernel width. He's going to have a height. He's going to have in channels and out channels. You could argue that in channels can be inferred, but I'm okay with being explicit about it. And I guess we just start here and then we kind of work our way up, right? So we can kind of go end to end and just like slowly replace this with a config file. I think that makes sense. Yeah. So I think that we just do like, we just are going to use a standard library JSON parser, I think. Parse from token source, I guess, is probably what we want to do. So we probably need like a token source, which is a std.json scanner, a std.json reader. Okay, so like, can this thing comes from an IO reader hype? Okay, this is kind of what we're looking for, right? So we're looking for some allocator where we're allocating this thing on. Is this a like scratch situation or what? probably this thing is short-lived, right? So even if the standard library JSON parser like has a bunch of stuff that it kind of like over allocates, we can probably like get away with that if this thing lives for a short amount of time. So I think that's fine. We'll just call this leaky. We'll let him know that it's like you're not really just getting back what you asked for. You're kind of like using this thing to do a bunch of shit. So you should clean yourself up after. And so this guy's gonna take leaky here, and then here we have a reader that is leaky and a reader, file reader, right? And so here we go like std fs, f is std fs current working directory, open file of this guy. We close this guy later. And then what? Then we like have f reader here. This is the JSON reader, like this. Does this thing fail ever? Doesn't look like it, but he probably has to be variable because this guy wants a pointer to him. So here we're like JSON reader, easy peasy, and options is probably I don't give a fuck. Probably. And here, I guess we just return this thing, right? Easy. Wait, that's fucking easy. Easy fucking peasy. Okay. So can we just be like config is equal to this config? I guess it's like this. Which means probably the file name should be capitalized, to be honest, to indicate that it is a struct in and of itself. Which means that this should look like this, and we're chilling. Okay, cool. So now somewhere we're gonna be like layer our config, parsed config is gonna be config parse of, our allocator here. I actually think I just want this to be back allocator like this. Fuck it. And the path is network config. Okay. We can checkpoint this guy. Let's do this. Let's do this. So we checkpoint our allocator, defer, restore the checkpoint, and then we can use this guy all we want. Easy. Easy. Okay. Let's just print this thing for a second. Okay. Network config is config JSON or something. And now stuff is gonna get mad. I don't give a fuck arguments here, probably. This guy's mad because what? Expected 4 arguments. T. True. We do have to say what we're parsing. So true. And now this guy should get mad that config.json doesn't exist. Okay. We do have to like propagate failures of the training thread somewhere, but for now, whatever. Okay. Layers. Expand tab, shift with equals 4, tabs equals 4. Okay. So here we want, how do we want to define this, right? So I guess we will see what the like natural Zig config format wants. Unexpected token, that's not very helpful. It might make sense actually to go the other way first. So can we maybe do something like config Zig, can we say print example? Let's just see where this goes. So we're gonna have like example is one of these guys. He's gonna be like layers is some slice of stuff, and let's put a layer definition here. So we're gonna like conv is something like this. Initializer is HE. Our width is, 3, height 3 in channels. Let's just do 1, 2, 3, 4 to be honest. Okay. And then can we do like std JSON? Write stream? I don't understand what this is. Std JSON, like, stringify. Here we go. And we want to stringify to some position, right? So we're going to take the example. I don't give a fuck with maybe probably with like indent, options here. This guy wants probably, I think it's like white space. Indent 2, okay, and then we're gonna write this to some output. So std out is IO get standard out. Then we can like std out writer here, easy peasy. And then here we can go somewhere and look at that example. So can we go to like main? Train thread, and just before we load it, can we just say like nn config print example? Because he's gonna get mad, but we might as well, give me some info first. Maybe we should only log on failure, this example. But that's reasonable, the way that looks. Hello? Paste, there we go. Okay, so we start with a 3x3, 1 to 4 or something. Something like this. It's not very concise. So, do we prefer, like, would we prefer if these things looked like the arguments without names? Like, maybe. Like, what's the alternative here? It's that this looks like 3314. Oh, I mean, that doesn't look great. Right? Like, this is definitely more compact in terms of, like, when I'm trying to see what this is, right? You could kind of have something like this. Oh my god, the P key just fell off my keyboard. That's hype. Right? Like, maybe this is nicer. It's like less ideal in terms of like explicitness, but like when you're trying to see what the pipeline is, you kind of want like at a glance info. So I think it is better to do it this way. So let's do that. So this, our layer definition, this is actually going to be, can we just do this, where it's a tuple struct? And then here, Leo, thank you for the 5 gifties. Much appreciated. Much appreciated. Much appreciated. All right. So this example is like way more fucking reasonable, I think. Way more fucking reasonable. Sure. Okay. So we start like this. Ooh, wait, hold on. Example. Yeah, that's right. Okay, cool. So now this thing parses correctly, which is good. And now we can start trying to build up the network from this thing. How do we want to do this? Do we want to finish the config first? I think so, right? I think it makes more sense to finish this thing first, then try to build it, versus trying to build up something piecemeal, because the shapes all need to match up. So let's just start adding in the different stuff that we have. So now we're gonna have RelU, which doesn't need shit. So let's do RelU. It's like this, right? Okay, and then we have max pool. And this is a U32. So this looks like this. All right, what's that look like? What's that look like? Sure, that's great. That's great. I'll take it. I will take it. Okay, so now we should actually be able to express something that's like pretty close here. RelU here, right? So we're like RelU max pool of 2. Right? Is that what it looks like? Yep. So then it's, you know, a couple of these. So we go, 4 to 8 with a RelU, 8 to 16 with a RelU. Then we throw another max pool on here. Then we have 16 to 32, 32 to 32 max pool. 16, 32, 32, 32, followed by a max pool. Then it was 64, 32, 64, 32, 64. Then it looks like we did a 64 to 64. Oh, some of these are 1x1 kernels. So it was 1x1, 8 to 16, 1x1, 32 to 32, 1x1, 64 to 64 down here. Right, makes sense. Makes sense. Then 64, 128. This is what we were trying. Who knows if these are reasonable? Okay, so now we need a reshape in here. So reshape takes in new dimensions. So reshape is equal to, 3 by 4 by 7 or something, whatever. Right? And then fully connected, and then I think that's it. Fully connected, which takes in, it's a initializer twice. So this is the wait spot initializer, bias initializer, in size, out size. Simple. So fully connected gets a HE 0, 128, 256 or something, right? Easy. Okay, super chill. So now here we need a reshape. And this is, it would be nice to be able to type math in here, huh? That would be nice, but so maybe that's interesting. Cuz this kind of sucks having to do it like this. And then also this is a bit of a problem. The fact that train num images is making it in here. We might want to make it so that our reshape layer is like independent of the batch size. It's probably better, right? So this guy should be... I was going to say write the calculation in a comment, but this is JSON, so yeah. It might turn into like a pre-process step. So either like you write the definition in Python and the Python exports the JSON or something so that you can do that. I mean, that's not like actually that crazy. It's like a little crazy, but not that crazy. Or you like allow these things to come in as strings. Or we like make our own config format that like, I don't really want to write like a math interpreter. That's kind of like annoying to have to do that. So I think it's honestly not that crazy to me to like have a Python definition of this thing that just like JSON serializes itself. That's not that crazy. But we'll see. Yeah, I want this reshape to drop the outer dimension. So this reshape layer... hello? What the fuck is going on? What the fuck is going on? What the fuck? There we go. Okay, reshape. Okay, so this guy is gonna be like, this reshape is going to take the input shape and he's gonna be like, get me input dims len -1. And so then we are going to be like, you know, we're gonna have like temp dims is, I guess, something like this. And we like build it up from... If we do this like var temp dims buff is like, surely we're not ever going to be like deeper than like 10 dimensions, right? That's plenty. So can we go like for self shape temp dims buff 0 self shape len, we have like in out or something, and we're like out is equal to in, and then we have like out at self shape len is equal to n, and then we do, this is like temp dims buff from 0 to self shape len +1. Seems like mostly there. What's he pissed about? Const U32 is not... What the fuck? Okay, so that seems to work. So now our reshape can just be like this. Okay, hype. Now, ooh. We actually might need... I mean, this shape does, in fact, depend on the image size, which is a little fucked. But we can figure that out later. So we might want to do something like, I guess that would be part of like the JSON blob generator. Yeah, that's fine. Right, because like one of the other things will be in here is like train num images. Like we'll have like train num images in here as well, right? We're gonna have like um image size in here as well, right? And so then if image size is here, then we can use that to generate this later. It's no big deal. No big deal. Let's not get ahead of ourselves. Okay, main. So we have reshape somewhere in here. 16 by 16 by 128. Let's just double check that I did that right. 16 times 16 times 128. Cool. So now we have fully connected, which is using HE initialization for the weights, 0 initialization for the biases, 32768 inputs, 512 outputs. We have another rel-u in here. Bang, bang, boom. Easy peasy. And then we do a couple of these iterations, right? So it's like 512 to 512, 512 to 56, 256 to 6. All right. And then at the end, we don't do a rel-u at the end. And then we do a reshape, which we don't have to do. That reshape is useless. Pretty sure. So this should be fine. Does it parse? Unexpected token. Okay, what are we doing here? Wrong here. Oh, wait, hold on. Oh, no, everything's broken. So it's line 30, column 26. Is it that reshape is just taking in, like, a raw number here? Oh, this is supposed to be an array, right? Yeah, all of these are arrays. My bad. My bad. Okay, that parses. Huge. So now we should be able to I don't know, create these layers based off the config. So for config parse layers, layer definition, we're gonna like switch, I guess we like create an output thing. So this thing has to be like dynamically allocated now. So this is gonna come from like, this is gonna come from like the heap allocator here, allocating a NN layer for the tracing executor. And how many of these are gonna be? Layer def len, probably, right? Config layers, config parse layers len or something. We're gonna make this many of them. And so then we go like, we have the layer definition and like the layer output. And so this is like, layer is equal to switch on layer def. Why is he not autocompleting for me? Oh, because f def ends with an f. So now we have convolution in here. We're like, try layer gen conv. Params here. And we can do like params 0, params 1, params 3, params 4. Is it this easy? Okay. Rel U, we have max pool. Max pool like this. We got fully connected and reshape. Uh-huh. Do you have to resolve the initializers from the identifier and the config? I don't think so. Oh yeah, you're well that's done here. Parameters here. So like the initializers are one of the parameters. So as long as we have the right number here, then we're chilling. So we have like layer gen fully connected. We just make sure we go like. I think that there's something stupid going on here where I should be able to like splat out these parameters. I just don't know how. So we'll just type it for now, but let's put a fix me on here and be like, can we splat the tuple? Like, actually, right, we know that we can do this because we have train thread here. This is exactly what they're doing, right? We pass in on spawn arguments to a function, and he must splat those out to call the function somewhere, right? It has to be done. So how is he doing this? Args. Oh, but in this case, it's actually a pointer for pthread, so that's actually like it might just kind of work itself out. Sure. All right. So this guy is mad what? No function name generate in nn config initializer. Oh, I see what you mean by resolve now. Yeah. I guess you're right. I guess you're right. Yeah. I see what you're saying. So this is like, I mean, we could make it so that as part of the parsing, we get like pointers to these initializers already. But like fuck it. It would be nice if we could just do like resolve on this, so I don't have to like fucking do the same thing over and over again. But in reality, that's probably like over engineering it, right? We can easily just do this. Who cares? Like init initializer is switch param 0. And then this gets like initializer here. And then it's pretty clear actually that this is going to be done multiple times. Well, what's he pissed about? So we should maybe make a function, like a little like initializer resolver or something. Oh, fuck me. And then these initializers are comp time. These are not like runtime interfaces. So we need to create like an initializer interface now so that we can resolve them at runtime. It's like the only option, I think. Interesting. Okay. So, okay, we'll figure this out in a second. Comment this whole block out for a sec. And this convolution guy now, he doesn't take an awaits initializer any type, but he needs like an initializer, right? Which means that we need an nnzig, like some initializer interface. What is like he initializer in here? He does take an executor in here, so it does. But I mean, like yeah, because he returns executor tensor, so the interface also needs the executor here because it's part of the API, whether or not it's like tracing or not. And so this guy, he is, I guess, going to take, this might be a dumb question what IDE you're using. This is just NeoVim. NeoVim with some language servers. Okay, so we have like vtable here, and here is gonna have like a generate function. I guess technically we don't really need the vtable. We can get away with just like generate function is this. So what does he take in? It's like all of this stuff, and he returns, you know, any error, execute tensor, chill. But now the actual input here is an any opaque here. Yes. And then now the actual generate function is going to take in all this stuff. He's going to store the any opaque pointer here. And he is going to call self generate function with context, alloc, fan in, and dims. Yeah. This dims now probably can't be an any type, right? You can't take like a function pointer to an any type probably. So that means that this dims needs to be probably just like an actual const 32 array, almost certainly. And we could maybe have like different versions of the function for like the different types, but like whatever. Okay, so now HE initializer needs to return, you know, this now takes in context like this. And because self is, you know, a pointer to this. Is pointer cast a line cast of context? Cool. And then we have initializer. So he takes in self as a HE initializer. He returns an initializer interface, and he's like, yo, my generate function is generate, and my context is self. Easy peasy, dude. This can be const pointer as well, and this can be const pointer here. And then we're kind of chilling. And this guy's gonna have like a very similar treatment. Okay. Which means that our guys who take initializers now can take an initializer here. And like mostly be chilling now. So like just where we did this before, this is like initializer. These functions are public. Okay, everywhere we have an initializer here, we go like this, and this should still compile. Can we just go like this? We go HE initializer, initializer. And then can we go back here for the 0 initializer, give them the same treatment? Okay. And then here, I think we fucked this up. This guy needs to take in a 0 initializer, easy peasy. Sure, true. These are, we need this is here because this is a generic type. And this guy's mad because we need to return the initializer with the right executor attached to him. So true. This guy's mad because we need to return this thing. And this thing's mad because he expected this shit show but got this shit show. Okay, that makes that easier. Here he's mad because he expected this, and we probably need to const cast here. Which is fair. This guy also needs to take in dims as const U32, like we said. Okay. This is mad because we need to take an initializer executor here. Okay. Surprisingly, that's all good. Does it like compile and run? Shockingly, yes. Okay, cool. That gets us a lot closer. That gets us a lot closer. So this conv stuff, we actually should specify the types here as well. Initializer executor. Okay. I guess technically these can stay as any types because our types will work themselves out here. I mean, it's not like ideal, but it'll do for now. For now. Okay, so here we're gonna make some sort of like initializer resolver. And he's gonna have like HE as an initializer. And a 0. Right? And here we're just gonna be like resolve. And here he's gonna be like config type is gonna be nn config initializer. Right? Yep. He's gonna return an nn initializer of math tracing executor. And here's just like switch on config type. You know, if it's HE, return self HE, and if it's 0, return self 0. Easy! Let's go, baby! Okay, so now here, this stuff gets simplified again. So this is, you know, initializer resolver. Maybe we say initializers resolve param 0, like this. And then here we can have like const initializers is an initializer resolver with HE is HE initializer and 0 is 0 initializer with these guys as their interfaces. Boom. Chill. Okay, we're getting closer for sure. Okay, so this guy's mad because I expected error union type found. Can this not fail? I guess not. All right. This guy's mad because when we create our fully connected, we need to resolve now. So we resolve this guy and this guy. Okay. Looks like we might be good. Okay, so that looks like it kind of parsed. Now we need to say, fuck this shit. And we just say const layers is equal to this. Break block layers. So now we should be loading from config. Nope. Because, well, I mean, I think we are. But something's mad. So here it's when we call reshape here. He is looking at num elms. Num elms is we probably need to duplicate some things here. Some memory is like falling over. Let's temporarily not restore this allocator just to see if that changes anything. Because like we must be out holding a reference to something we're not supposed to. Yeah. That's surprising. Surprising. Okay, but yeah, what the fuck? Scratch. Because the scratch allocator is literally only used to get this config parsed. We do look at these layer definitions, but these layer definitions should be in like useless after we're out of this shit. Right? So like what the fuck is going on here? I guess maybe our reshape here is probably storing this thing without duplicating. Yeah. So here we need to make sure that we are copying these things. I think that makes more sense. Oopies. Nobody else is doing some dumb shit like that, right? So we should be able to go back to clearing our memory for the config parsing. And looks like we're chilling. Okay, so we can prove to ourselves now that this is useful because we can go into this config now and we can just like completely like hack this shit to pieces, right? So we can say like copy config JSON, config2 JSON, and in here, let's just like take the first layer. Let's do like a 4 max, like max pool it down twice. We're gonna make this thing way smaller. You know, do a little bit of this. 8 here, then we can keep the 64 here. But what we should see now is that it goes way faster. Oh, this is config 2 now. So we should be seeing like iterations just like fly through now. Still not that fast. Maybe we reduce numbers even further. Let's just take these guys. 8, 8, 8, 8, 8, 8, 8. And then this is what was it before? It's like 256 times 256 times 128 is what we said? No, 256, 256. What is this reshape? Oh, sorry, because we've max pooled. So it's 256 over 4 over 2 over 2 is 16. 16 times 16 times 128 was what we had before. Yeah, so 16 times 16 times 8 is what we have now. So this is 2048 here. And we can do something like just go straight to 6. And we should see this guy start to fly. Oh, but we're nanning off rip, which is funny. Do we consistently nan off rip? Yeah, there we go. There we go. Cool. Cool. So now we can load different configs, different network definitions, and get different behavior, right? So we can go back to config 1 here, which is like a much more expensive network to run. And we're back to the slow way. That's sick. Epilepsy goes burr. Oh yeah, sorry. Oopies. So that's pretty sick. And this, in reality, should be stored as its own commit, probably. So we'll kind of say that this is layer definition via config, or like runtime layer definition. Okay. I would like to actually add a little bit more here. So I also want like, I want the like number of images and the image size to be defined by this thing. Ooh, wait, maybe not. Yeah, this is interesting. So we have to be a little bit careful here in that we kind of have like this like generic neural network layer, this neural network config, which should be things that are like generic to neural networks. And then we have kind of like external stuff like batch sizing and like training parameters. We need to be careful about where we store these things. So if I want like num images and size to be part of the config here. I think that what we need is here we would say like network kind of lives in its own structure like this, right? And then externally to that thing, we can have stuff that's like num images and like image size. And we just have to think about where these things belong. Okay, so here we're actually going to have like our config, our like specific config for this training task of barcodes. So here we can be like config network is an nn config. Yeah. And then we have whatever the fuck we threw on top of this thing. So num images. Like batch size maybe is a better name for this. And then we have also the image size. And we have a parse function here now. So it's possible that this parse function just gets like completely nuked from here and lives here now. And he does kind of like the same shit. And it was just now we do like nn config parse. This is just config parse now. And we have network layers here instead of whatever the fuck we had before. Okay, cool. And now we should just also pull some other stuff out of here, right? So like train num images, this thing kind of like needs to go away. And barcode size also has to go away. And now everyone that uses them have to like get that shit propagated from the config. You know what I mean? Okay, so this guy now is like, oh, what's happening? Why is barcode size in here? Oh, it's down here, I see. Okay, so now this guy's like, yo, you're using barcode size. I don't know, we'll do this for now. Barcode size is config parsed. Image size, we have train num images is batch size like this. Now this guy's like, yo, that shit's not defined yet. True, so this config, oh, also this is in the main thread. Fuck. Why does he need that? Just a clamp. Just to clamp. So we can kind of, for now, I'm just gonna hard code this to 1. And find a way to like fix this later. Fix me, train thread needs to tell us how many images per batch. But we'll get that later, which makes this go away, which helps a little bit. Okay, so generate training input. He now takes train num images and barcode size here. And then shockingly, everything else kind of works. So can we give this stream treatment to config here? Okay, so can we load config to JSON now? Unknown field, fuck. So we know that like the layers part is fine. This feels like it should be fine. Can we get like a little bit more information about this thing? Oh. My bad. My bad. These things need to be the right. Also these batch sizes, I think we're wrong. I think we had 64 before. Nice. Okay, so what we should see now is if we up the maybe we change the batch size to like 128 here. This is in config, so let's leave that one. Let's look at config 2. We should see this get slower. Okay, so he's still moving. Double it again, give it to the next. Yeah, so we do see him start to slow down there, which is good. That is good. And then what if we take the image size and like half it? So sorry, let's half it and then change this first max pool to a 2. So that should make everything else kind of like stay the same. NAND off rip, sometimes that just happens. I need to figure out why. I think there's some uninitialized memory. Yeah. So now we see it going way faster because the initial image size has been like halved. So that's sick. Or quartered. So I think that's working. What's that learning rate in the GUI? It sets the alpha parameter on the Atom Optimizer. So we should have that in here as well. You know? So here we should have like this lives here probably in the network config. Probably. Okay. And then where the fuck does that go? So default LR, this thing has to go away. This thing comes from the config now, so this comes from something like this. A lot of this will come for free now. Now we have the same problem here where the initial learning rate needs to come from the training thread. Or we just have to parse the config twice. That might be the easier way to do this for now. To be honest. Yeah, you know what? I'm just gonna do that for now. That's easier than like coordinating between threads. I can plug Optune into and let's do a thing overnight if you want to do hyperparameter optimization. I'll have to look that up, but that sounds cool for sure. Yeah, let's just do this. Like, just fuck it. Allocators, scratch, checkpoint, defer, allocators, scratch, store. Easy peasy. And now we can just do this with like config parsed, network, LR, and config parsed. Batch size. Or was the other way maybe? I don't remember. It was batch size after. There we go. We'll live. All right, so Jesus Christ, yeah, there's something going on here, right? It's so obvious that if our numbers are this high, there's like that's an uninitialized float if I've ever seen one. So if like, but like, let's just jump this up to like, 05 or something. So this is 05 here. Yeah. All right. Cool. Cool. Okay, next up, I would love to fix that, like, uninitialized memory thing, but I think I can do that. I can take a look at that off stream, because, like, it might be really complicated, it might not be. But I really want to, like, make it so that we can keep the data that we need to keep for now, right? So the focus needs to be getting us to the point where our, where we can set up experiments, and then whether or not those experiments like run well is like a problem for another day. Okay, so comparison graph data. So we are eventually going to want to compare the outputs of these guys to see which network was better, which thing do we like better. And so I guess, actually, hold on, let's commit what we had before. We'll call this whip add batch size image size lr to config. Okay. Figure out how we want to group this stuff later. But in terms of graphs, we want to graph probably like loss over time, right? And maybe loss over iteration, right? So we want to see, and maybe loss by number of images is probably the thing we're going to look at right now. Eventually, we're going to have some sort of like real statistics, right? But for now, I think it's just that we want to know in wall time, did this train faster? In iteration time, did this thing train faster? Because maybe like wall time can be affected by like CPU load, so you kind of want to be a little bit careful about that. But also, if your like batch size changes, then like each iteration will take longer, and so you need to capture that information at least a little bit. Ah, shit. Internet died? That sucks. Oh. God damn it, dude. Alright. Well, if we're dead, I guess we're dead. That sucks. Well, okay. YouTube outro, I guess. YouTube, thanks for watching. Sorry for the early stop. Luckily, we ended on something like somewhat satisfying. If you like what we saw, we stream most days. We aim for 12:30 Pacific time to 4 o'clock Pacific time. Yeah, there's a Patreon. There's a, you can sub on Twitch. There's a YouTube member thing if you want to support. But otherwise, I think that's it. Thanks for watching. YouTube, peace out, and Twitch, let's find someone to raid.